Welcome back to the shop. I've had this clamp laying around for a little while and I've been wanting to restore it and make a video about it, but I've been pondering how this works and how to try to describe it, how to articulate, why I think it's so novel. And it took me some time to sort of think about why this is different and how it might compare to other ones. And I had initially thought that I should buy a force gauge and try to test all this other stuff, but I was into the hundreds of dollars by the time I would have figured out some way to, possibly measure the forces, and that would ultimately be just a penalty on me being bad at math. I talked to a buddy of mine who's good at math, and it always comes back to if we just modeled it in some software, that'd probably be the best way to do it. But all that is not very practical for people that don't want to, sit down in front of a computer all day long and just want to work in the shop. All that being aside, what I'm going to try to do today is explain to you what I think is happening with this clamp and why it deviates from other clamps. And this is a cam style clamp, and it slides back and forth on this I-beam. It will get cleaned up today at some point, but just everybody knows your standard C clamp and the types of threads, the number of threads per inch, the minor diameter, the major diameter, the torque loads, all the other stuff that goes on to how tight a clamp can be. There's a lot of math that goes into that, and I believe Jason from Fireball Tools goes in and does a whole series on the forces and actually measures the stuff. It's very interesting. But there's all sorts of different clamps out there that just boggle the mind when you go to calculate the forces. So not only does this have all the other dynamics that you measure for a typical clamp, but then you have this action here, and this was one of my restorations a long time ago, and this is really a great clamp because what it does is as it pushes out here, it tightens up, but it doesn't have that torsion load, when you tighten these down and it wants to turn or walk and move the work back and forth. That has been a real problem, but apparently there's other people trying to solve that problem, and they've done an outstanding job. That is these Cant Twist clamps. They have a similar, the same benefit in the sense that these clamps toggle together, and there's very little propensity for this to weeble wobble back and forth because the forces are, it's that linear force, not the axial force. It just wants to squeeze. It doesn't want to twist and squeeze. So it's very interesting, and there's many types of clamps out there as you can imagine. You've probably seen them all. I love these little clamps, these little bar style clamps, and I've got some Bessey clamps. They are what I look for when I go to the flea market. That is absolutely the kind of stuff I look for. The Cant Twists and the Bessey style, the expensive ones of these. I've got another one tied up in a project now. But let me digress and get back to what I was talking to about this cam clamp and how it might relate to a typical clamp. So this cam clamp effectively has just under a ½ inch of travel. When I have this in the closed position, obviously it needs to get cleaned up. In the closed position, the distance from here to here, this gap will disappear as I go all the way out. That's roughly 1/2 of an inch. And what's interesting is I have just over probably 180 degrees of turn. You've seen how that goes. Just about full circle there. It can go a little bit further than that, but effectively it's about 180 degrees, I would say. So what you've done is you've moved a ½ inch in 1/2 of a turn, and that's quite a distance for a clamp. If you took this clamp, let's say this is 5/16 18, and you wanted to move this a ½ inch, you have to turn this 9 times. 9 times for it to move that ½ inch. And what we end up looking at here is, and again, it's hard to articulate, but what we have is a graph, and effectively, let me zoom in here, and I'm going to do this upside down for you. So I have this clamp that moves 180 degrees. It moves a ½ inch at 180 degrees, and these numbers are rough figures. So this is effectively 0 inches, and this is going to be a ½ inch. And that's just, you know, 180 degrees. But here, if we pick the same point here, and I just arbitrarily plotted this at you know, 10 teeth per inch, half inch, no, inch. Yeah, I arbitrarily plotted this at 10 teeth per inch. You know, we can see 1, 2, 3, 4, 5. If we had a 10 tooth per inch thing to get the same level, so you know, we'd see that 1, 2, 3, 4, 5. So 10 full revolutions versus 1/2 of 1 revolution, which is very interesting. So I would go ahead and say that this has got far less clamping force than a typical screw style. However, that could be beneficial if you're taking clamps on and off quickly all day long. Okay, so hopefully that gives you some idea, and it's probably intuitive to most people. Just for me, it was a little bit different. I was struggling with trying to determine whether this was a better clamp, stronger clamp, or less strong clamp. And I think that, you know, it took me sitting down in front of a computer and, you know, putting pen to paper before I figured out that this is, you know, obviously you're doing much less work and getting that great distance out of it. So I'm going to say that this is probably a weaker clamp, but again, there's different clamps for different kinds of work. All right, let's clean this puppy up and we'll see what she looks like. I know there's been a lot of new people to the channel in the last, you know, 6 or 9 months or so. It's going pretty good, so I should probably touch on what I'm using now. This is the 3600 RPM, yeah, 3600 RPM Delta half horsepower wire wheel. Of course, it's got no guards on it. None of my machines have guards on it. I'm not saying you should take yours off, but when you're working with certain things, the guards can, you know, obstruct your view. And this has 2 coarse wire wheels on it. And this is usually the first wire brush that I go to when I'm doing some rough cleaning on things. They're both Forney wheels, I believe. Forney seems to make pretty good stuff. But so I'll use these and probably go to a finer wire wheel as we go through, and I'll try to explain the machines and the RPMs and what, you know, why there's a difference. So I went over the bulk of this with the big wire wheel here, and this is probably my least favorite. It's a good tool, but it's not pleasant to run because it's powerful. It's by no means the biggest one out there, but it's still moving. I mean, it's got a lot of energy, a lot of potential energy, and it can just take this tool and send it across the shop in no time at all. So you really have to have a good grip on it. You want to try to, you know, make sure you've got 2 hands on it, and you can't get too fast and loose with these bigger machines, the high-speed half horsepower ones. Some of the cheaper ones you can stall them out easily. This Delta's nice, and I picked it up at a garage sale for $10 or so. But now I'm going to move on to the slow-speed machine. That's going to be right behind here. I'll move the camera for that. And this is the 1700 RPM, 1725 RPM, and it's more pleasant to use, but it's also got the aggressive wheel on it. It does a good job getting into some of these other spots, and you feel like you have a little bit more control over what you're cleaning. It's probably not as fast, but again, it's a little bit more pleasant to run, so in my opinion. So let's move on to that one. So this is my PowerTech slow speed bench grinder off Amazon. Been a great machine. It's impossible to tell with the camera, but this is, you know, much less intense. Alright, now I'm more than capable of going through and cleaning this up with the wire wheel, but, you know, I think I just throw this in the Media Blaster real quick and be done with it. Alright, I've done other videos on the Media Blaster. I've sort of just got it rigged up to my smaller compressor now, but it should be more than enough to just dust this off quickly, so we'll dust it off and then take another look at it. Alright, so that did a great job getting into all the little nooks and crannies, but after it sort of fascinates this surface, it sort of raises the metal a little bit. I like to bring this over to a little wire wheel and use that to give it a good finish on it. So I'll show you that. This is just an open face Marathon motor I picked up from somewhere and then put an arbor adapter on it. I use this thing all the time. It is a great tool. So shit. Yeah, that gives it a little bit nicer finish. Let me look and see what I have for paint. See what we're going to do next. Alright, so there it is. There's my cam style clamp. I'm going to let that dry. This would have been a real bear to try to tape off, so I tried to use the paint marker. Probably give it a couple hours to dry, maybe come back tomorrow and touch it up. Paint markers have been a great tool. I forgot who turned me onto these things years ago, but they're just outstanding to use. And I can't find my tester's paint, so that sort of weighs into the equation also. After I get done tinkering around with the paint, then I'll go back and finish it up with some Johnson's Paste Wax. And that should make it work nice and smooth on here. And for what I've seen the woodworking guys, they use paste wax on their table saw tops, and it's a great tool because the paste wax, I think I doubt that it won't make too much of an issue if you were using this on wood, and then it would keep it from accepting the stain after the fact. So that may be something you want to think about when you're finishing clamps. If you're going to be using wood or whatever, what would you want to do to not impart any sort of chemicals onto your surface, your finished surface, that is, especially with a fast acting finish clamp like this. And anyway, so that's it. I just wanted to get something on the channel and get something out there about this. It's been very interesting, and I hope you enjoyed it. So thanks for watching, thanks for subscribing, and have a good night. I almost forgot to show you how this thing works. Oops. Look at that. That works great. Then the cant twist. See, it has no torsional tendencies. And this is just great. That thing will absolutely send it home. This is just the best clamp in the world. It's a grand clamp. If you ever see one of these, pick it up. They're just tremendous. You really have to straighten something out. This is great.